BSides DC would like to thank all of our sponsors, and a special thank you to all of our speakers, volunteers, and organizers for making 2018 a success.
Hi, my name is Ken Jenkins. We're going to have a talk today about security control validation using threat behavioral based emulations. This talk's kind of more focused for blue teamers, but I think the red teamers in the room could kind of take a little bit away from this. So what we've kind of done is, instead of the full spectrum red teaming, we break down into very small chunks. And the focus of today's talk is on traffic, so iterating through different types of C2. As I said, my name's Ken Jenkins. I've been at IronNet for about 2.5 years. I lead the red team there. Prior to that, I was on a DoD red team, blue team, hunt team, worked in a big SOC. Prior to that was network systems engineering. I retired about 2.5 years ago from active duty.
Hi, I'm Stuart McMurray. I'm a little confused about mics, how they work. No, I'm Stuart McMurray. I'm a red team operator and developer at IronNet. I focus mostly on Unix operations. Before this, I was at a Fortune 500 red team. Before that, I was an officer in the Navy.
Yeah, so big shout out to Greg Conte. He's one of our mentors, a senior strategist at our company. He leads a lot of talks. I think he's been at Blackout every year for, I don't know, forever. Good guy to follow on Twitter as well. So disclaimer, you see a lot of these at the talks. This one right here is no different. The big thing is, consult with someone before you start doing any of these activities. And obviously we're not here to preach about our company's policy and disclaimers. Here's kind of an outline we'll follow. We'll address the problem that we see. A lot of red teams, they jump into a network, they do their thing, they give their out brief, maybe their hot wash, and then they jump to the report, and that's about it. Every now and then there's some follow-on. We talk about how threat emulation helps your environment. You don't have to be a red teamer to do threat emulation in your environment. We'll talk a little bit more about that. And then bad days, no matter what we've done, every time we show up to a client's environment, something goes wrong, so no matter how much you plan for it. We'll discuss a Fortune 100 engagement that we had recently, and then Stu will jump into some of the coding emulators we have and tools, and then we'll close it up with some lessons learned. So what's the problem? Our enterprise environments have gotten so big. The complexity is crazy. Defense in depth is pretty deep, and then it's usually distributed how it's managed between the IT team, the governance risk compliance team, the CISO's team, the hunt team that's providing Overwatch and the SOC. So there's a lot of ownership there, and there can be misconfigurations along the way. So we definitely want to not make assumptions whether something's configured correctly, and want to test the security controls. So what is emulation? What's to address that last slide, emulation is more to kind of counter those problems. So you're not waiting till a bad day's occurred and your first breach in your organization has happened. Instead, you'd rather exercise that a few times, and we see a lot of organizations doing tabletop exercises where they rehearse what they will do if it happened, but they don't actually rehearse when it happens or prior to it happens, like hands on keyboard. So it's good to conduct some emulations, and like I said, we're going to break out very specific things we do for some of the red teaming that we do. So what are uses of current cyber threat emulation? Mainly it's to test security controls, endpoint to internet, but it's also people, processes, techniques, people, process, technologies. And then as I mentioned a moment ago, you want to exercise that incident response plan, but you don't want to just exercise it on paper or in a sandbox. One that we've been kind of working on a bit is testing sensors and network protocols. So in a lot of our clients' environments, they have these huge gigamon spanning and tapping infrastructures, and a lot of times that's not tuned effectively for the IPSs, IDSs. So we'll kind of go into that a bit and show you how some of the gaps that we've discovered. No matter how many tools you continue to deploy in your environment, you're always going to find that something's not deployed exactly as you thought it was. If you're in the government, maybe you're following STIGs, but someone somewhere responsible, didn't configure something correctly, or it was an oversight, or there was a drive-by fielding, whatever it may be. And then one we also work on is validating your vendor's claims. Fancy vendor comes in with their box, their appliance, their super sexy sales engineer comes in and starts demoing the product, and you're wowed by it, and you move to purchase. Do you know it really works? What we do here is we kind of show off how our behavior analytics work. Next is to generate artifacts. For ours specifically, it generates PCAP, a bunch of log files, and you can give that to your hunt teams to use for those IR exercises and training and testing. So how is it currently being done? Generally, you negotiate with, I say you negotiate, a client reaches out to you, you negotiate a contract, you come up with your objectives. It's all about the customer's objectives, right? Not just what does the red team want to do and what can they get away with. And generally, red teams take the least path of resistance. Normally, you fish your way in or get some kind of assumed breach access, and then from there on, you start conducting ops. Usually, C2 is a given. So I was at a class a couple weeks ago at DerbyCon, and some of the red teams say, hey, we have a hard customer, so we just domain front. That's just a given. When we go in, we domain front from start to beginning, and we don't really worry about C2. We're really worried about keeping our access and seeing what we can do on the endpoints and servers. So not really iterating through. So, and what is within the C2? Usually is beaconing or some kind of tunneling over DNS, exfil over DNS, but definitely not iterating. So what I mean about iterating is the different beaconing intervals, the different jitter intervals. Are you switching domains as every other callback, or are you using different types of DNS tunneling? Are your subdomain links, the queries, are they a certain size? Are you changing that up, or are you just sticking with what's publicly available that's been signaturized? And then generally we do it as well. We buy a good reputation domain, maybe off expireddomains.net, and then we kind of park it. We have a static site up that keeps the reputation building. Before we go to, before we go to customer engagement, we may go and check to see if, what's the reputation look like now? We try to discover what that customer's proxy is before we get there and see if our domains are categorized correctly. But then we live off of those one or two domains that we use while we're in the environment. A lot of red teams have the short and long haul comms. They probably have some kind of DNS beaconing, for long haul comms, and then for short haul comms, they're probably using some type of beaconing. But they generally don't iterate off of that or use different intervals, except when they go interactive. So exercise and endpoint only. There's a lot of talks going on about how to privilege escalate, how to bypass all, app blocker, different EDR solutions. We got one of the celebrities in the conference room, Bo Ops, sitting in the front row. He's got a really good blog going on, exercise and endpoints. But we're not really stressing the network. Network's kind of a given for red teams. If network segmentation isn't quite right and proxies aren't tuned correctly, generally you just go right in and out of the network. Often the defenders, CISOs, whatever it may be, they don't work directly with the red teams. Maybe it's just for a pro services engagement. You come in, you hand the objectives over to the red team, you agree upon it, and then you start exercising that. But afterwards, long term, is like that iterating through training with the SOC or the other defenders really doesn't happen a lot. So I kind of touched on the next bullet, a lack of training afterwards. I don't think you should leave an environment with some tool you ran there or some technique that you're not kind of sharing with them and saying, hey, we might want to go look at this. Maybe you don't turn it over completely. And then I don't think we've talked to a red team that lately that does anything with like domain generation algorithm. So we like to test this in environment. So DGA's domain generation algorithm, it's a algorithm that creates a whole bunch of queries. And the malware developer at one point in time has registered a domain that he knows that algorithm will query out to. We'll create a query and query out to that domain, and then he has command and control C2 rendezvous. So we like to iterate through different types of DGA during our engagements. So for the red teamers in here, you're like, yeah, thanks, Ken. Yeah, planning, you definitely got a plan. So some of the things we realize is sometimes we're too real with our CT, and it doesn't benefit the defenders, if they can't catch it all, or they're just not aware of those techniques, other times it's perceived as not real enough. So you got to find a healthy balance there for the SOC team to really feel like they got something out of it. And then not to be negative here, the SOC may or may not care. So it may be MSSP, it may be a contracted red team that doesn't belong to, contracted SOC team that doesn't belong to that organization, or they're just being pummeled with tickets and alert triage that they just can't participate in the engagement. They're just waiting for the aftermath of the engagement. Another thing is sometimes you use malware. You want to use malware that instills confidence in the client that you're working with. So we have defanged malware that we used. So we're building these emulations based off of intel reporting that has occurred. One thing you don't want to do during these engagements is focus on the minutia. So my security controls will detect within this beacon interval and with this amount of jitter and with this amount of subdomain label queries, and then bike shedding. This is one Stu kind of turned me on to with developers. So you're buying a mansion, but you're worried about the color of the bike shed that's being built next to it. That's not really what the goal of this is. You're trying to focus on the little things and see how your security controls work. So avoiding the bad days, we've all had them. No matter how well you plan, you're still going to have them. So we definitely run everything prior to an engagement. Generally, we have a pretty robust testing infrastructure. We also are contracted with a company called SimSpace. It provides us a really nice training environment. So we detonate everything before we go to the customer sites. We kind of know what security controls, how they'll react. We know what our stuff looks like on the wire before we go. And we try to keep it as simple as possible, but at the end of the day, we're trying to emulate characteristics of advanced threats. Clear written scope of testing. So oftentimes you can go in and do something very complex, and it's kind of out of bounds. So we separate this from like full spectrum red teaming. And then communicating your infrastructure ahead of time, telling your customers, your clients, what exactly does your infrastructure look like? Where is their data going? How is it encrypted at rest and in transit, especially if you're doing any type of exfil? So communicating that ahead of time has really paid dividends for us. It's pretty wide open when you're talking to a particular client on this. And then having everyone know what's going on. So we see that some of the responsibilities of securing an enterprise are so distributed for large Fortune 500, Fortune 100s. So it's good to try to bring everyone in so they kind of know what's going on. We ran into one environment where the proxy was not controlled at all by the SOC or even under the CISO. It was an IT team, and it took days to manipulate that proxy if you needed to whitelist something. So that was very difficult to deal with. One thing we do, I didn't bring it up in the slide deck, but we track everything. So we have source, destination, we have the technique we're testing, we have remarks that we leave behind, and we provide that to the client. It's basically an entire list of IOCs they get based off the traffic that we've generated in their environment. So for planning, our goal here isn't to test every single security control. It's to test a very specific technique, or with the rise of behavioral analytics, is to focus on a particular analytic. Just to say you have that analytic that detects beaconing or domain generation algorithm or any kind of C2 over DNS. Do you know? Have you tried it? I know most SOCs don't really have the ability to try all those things. They probably have to rely on a red team. And most red teams are using pre-canned tools. Every now and then some of the really advanced ones develop their own, but a lot of those tools don't get brought to every engagement. Like I said, least path to resistance. Again, we mentioned appropriate personnel being informed. And then we generally have a menu of items that we know we're going to emulate before we arrive. We know exactly what tool we're going to use. We generally provide the client a list of emulations that will run at specific times, from in-brief all the way to out-brief and final report. And then we tell them why we're going to use it. Like if we have a certain emulation that's been developed, we generally try to map it back to a known threat. So we're not just coming in here to show off that we can code or that we can create emulations. It's more like, hey, this is realistic. APT such and such use this. APT such and such use that. And hey, if you can't detect these, you're probably not going to detect other threats. And then obviously written permission. This kind of goes without saying, but I've seen going to the engagement where the right person wasn't involved from start to finish, and then they show up when you show up. So just try, that's just something you have to work through when it occurs. But if you have that, if you kind of understand their org chart before you go in, it's very helpful. So gotchas, we've always had gotchas. So we generally look across the different AV and proxy vendors and say, hey, how are they categorizing our domains? What is the threat? What does the reputation of our domains look like? We query domain tools for all our domains, and we constantly try to have them parked, where they're not truly parked, but and then having a plan B that's actually been tested. So I'll discuss that here in a moment. The other thing is, don't leave your devs out of reach. Fortunately for me, I have a really good dev a couple of really good devs on the team, so they're never really left out. Next is make platform agnostic tools. So we agree upon a lot of things in statements of work with clients, but when you get there, you may get handed a different OS. Maybe it's Linux, maybe it's a VM you brought with you, maybe it's your own machine, maybe it's a victim they identified for you. So we try to make platform agnostic tools. So I was talking about a Fortune 100 earlier. This organization, it's a large pharmaceutical. They had every security product that you can imagine, several EDR solutions on the endpoint. They had a managed service provider providing Overwatch, who was pretty sophisticated. They had a fusion cell, they had a SOC, and then they had a security team within their IT team, which was pretty interesting. And they had, they pretty much participated in the exercise. So we agreed, we'd deploy them a VM, because they said, absolutely not, you're not bringing in your laptops. That's just not, that bypasses all of our policies, and that's a huge violation. But they would take a VM. So we packaged up a VM, had our framework on it, we sent it forward, deployed it in their hypervisor, gave us SSH access to it. Then the victim they provided us gave us RDP access to that victim. So that was pretty interesting, pushing tools over to it. So we quickly started running our tools off the victim they provided us, but we continuously had to change up our infrastructure to match what was going on. On this one in particular is interesting. They had a pretty locked down proxy, but like ML and GA domains, top level domains, where we register them on site that morning just to have spares, and those actually worked. Some of the more secure ones, the ones that had the reputation actually didn't work. So what I'm seeing is if your domain's if your domain has got a good reputation, generally it gets out. If your domain's uncategorized, maybe not. So for the red teams, I'm sure it's pretty obvious, but you definitely want to look across that before you show up with their proxies. One thing we noticed here as well, there was some DNS round robin in their network. So every time a query from our C2 over DNS would go out, like about every fifth query would go to a different DNS server internally, which is, for the defenders in the room, think about the complexity of that with trying to use like a signaturized tool or some kind of behavioral analytics. That means you're likely only seeing every fourth or fifth query, or 1 in 5 queries maybe. So they had to retune kind of their Gigamon infrastructure to test that, but no one in their organization was really looking at that. So you could exfil over DNS all day long, and it wasn't a problem. And for the tools they had internally that would catch that, there just wasn't enough network artifacts to trigger anything they had in their environment. Also, if spanning and tapping infrastructure is saturated or is filtering going on, if you're not catching, if you got a beacon is going every 10 minutes for an hour, that's 6 beacons in arrival, six beacons in arrival in an hour. If you had a bit of sampling or saturation in the environment, you might get 3 or 4 or 5 of those beacons, so not enough to trigger an analytic, maybe not enough to trigger a sensor. So they also relied heavily on IDS and IPS signatures. Other than that, traffic-wise, that was it. So if it didn't get caught on the endpoint, the proxy didn't catch it, it went out the front door. So I'm going to kick it over to Stu for a second. Well, for the majority of the rest of the talk, to kind of go into how we do these emulations. So Stu primarily codes most of our emulations along with the rest of the team, but and he's got some pretty interesting things he'll share with you. So I'll kick it over to him real quick. Thank you, sir.
Hi, I'm Stuart McMurray. I wrote all the emulations. So talk about what exactly we mean when we say we run an emulation in a client environment, and furthermore, how the blue guys can run them without having to involve a red team, pay for a red team. So what do we mean by an emulation? Well, it's a thing that does a thing. Usually it's a program, or it could be a script, sometimes just like a command. We'll see a couple of those that we've run. And the idea is it does something hacker-ish. It makes some usually network, but no reason we couldn't do endpoint stuff, and we have as well. Something that is meant to trigger an alert or test the bounds of a sensor or an EDR solution or whatnot. So broadly speaking, we'll just call an emulation. They tend to be malware-ish. A lot of what we use could, with minor tweaking, be used actually to have C2 or actually do have exfil. But safe. There's no need to introduce risk. We're not trying to prove, yeah, we can get comms all the way in and out. No, we're just trying to say, hey, where does our emulation, or excuse me, where does our tool stop? Where does EDR stop alerting and start saying, yeah, it's probably all right? And then these are generally much smaller in scope. So when I write these, I write them thinking, okay, I'm going to do one thing, and I'll put it on a box, it'll run, and I'll get a result. So I'm not thinking, okay, I got to deploy this everywhere. I need to be able to pass a shell to that guy. So it's very, very small in scope, also cheaper than red teaming. And we found these are actually pretty good from a science point of view, from a, hey, let's do some security research. So not only can we use them red or blue side, we can say, hey, yeah, I'm testing this neat theory, or hey, I want to see, I think I found a workaround for this thing. So what makes a good one? First, they have to work. So that, they don't work, you don't get it very far from that. And then they have to work without help from IT. So Ken was mentioning the one time we tried to deploy a VM. We did deploy the VM. And then IT was like, yeah, and you actually have to go through this Windows endpoint to get to the VM. And you got to Citrix yourself to the Windows endpoint to get to the VM. And that really isn't what we need. So yeah, make them work without IT's help. This also means make sure your domains don't need whitelisting, or maybe they do, maybe that's what you're testing. But generally the simpler the better. Also, they don't trip unintended defenses. So if you're testing like, hey, do we see something that makes really long DNS queries? You write it, you put it on the box, AV flags, quarantines the box maybe, done that before. That, you don't actually, you test your goal, you test that something works, but you're not testing whether or not the one defensive tool you're trying to work with works. It's kind of alluded to when we went to that one pharmaceutical company. You don't necessarily know what sort of targets you're going to run these on, or what sort of endpoints. We found we get on site, the people in the meetings, the planning meetings, were not necessarily the people who ought to have been in the planning meetings. And so like, no, you can't do that. Who let you do that? Here's this one box you get. It's really old. Hope you have something that works. So having things that generally work everywhere, and that also means not a lot of dependencies. Ruby's a cool language. Ruby gems are less cool. So if you need like this many dependencies, maybe we don't code like that. So when we started doing these, we're like, okay, we'll emulate bad guys. We'll have domains that look really sneaky. We'll have googlelogin.co.uk, for example. Please don't go searching for that. That was not one of mine. But we'll have things that are, nobody's going to see them. It really doesn't help in the sense that, we'll get past our tools or be caught by the tools that we're meant to be caught by. But going back through it, it's kind of hard to look. It's like, if you're not paying attention, Google with a 1 instead of an L looks enough like Google, you'll miss it, and that's happened. So instead of things like that, register things like ilovekittens.com. Really long, really visible, probably not actually used by somebody malicious. These tend to be cheap, especially if it's blue team running these things. You probably have actual defense to do. And for something you're going to run for 5-10 minutes maybe to test a thing, you really don't want to spend a week of dev time on it. So, simple, cheap, not hugely complex. And then finally, credibility for these. We'll run these, and almost all the time we get back, yeah, but that wasn't real malware. If it were real malware, we would have caught it. And you have to have some way of saying, well, actually, just let me change this. It could be. We're not going to do that for you because we don't need to put you at any more risk than you are. But credibility is actually a pretty important part of this. My secret weapon for all of the above is Go, the programming language. It's quite easy to learn, quite easy to use, and it compiles for just about everything you're going to find in an environment. even mainframes actually is a mainframe target. So I encourage anybody who's going to run these to look into it. So a few things that I've learned doing these, as far as especially safely, but just coding these in general. It works a lot better if your emulations do one thing and do it well. When we started, we had this really great large framework. It had everything you could possibly want built in, and it had every bug you could possibly want also built in. So learn quickly, okay, we'll just write one tool to do one thing, to test one thing. We'll write one tool to just make HTTP beacons over and over. We'll write one tool to emulate ZBot or Zeus, and it actually works pretty good that way. Another thing I've learned is to handle text streams. So it's really easy. You output JSON. You can read JSON into your sim. Splunk loves JSON. Until you actually have to grep something out of it, until like Splunk isn't doing quite what you need, and you're just like, hey, let me grep. Text streams tend to work, and it's really easy to write something to convert that into whatever format you'd like to use. With safety comes readability and maintainability. They go hand in hand. And this comes usually later when you say, hey, intern, make this thing do this thing. And the intern's like, oh, I can't really read this, but I think here's where I need to change it. And you forgot to mention that that affects that, and that affects that. So readability, maintainability, just good general software engineering principles go a long way to make these safe and just to work well. Testing is important. If you don't test, you never know what you're going to come into. And speaking of unexpected things, the last bullet, expect the unexpected. Hey, your malware is still running. I don't know, we killed standard out, but it's still running. So testing, typically you have to test these to a point. You're never quite sure because it's not running in the exact target environment, but testing as much as you can is very important. I'd like to go over a couple of the emulations themselves. We run a couple of the specific tools. Both of these are publicly available. Both work pretty well. So the first one is DNSBotnet. I actually wrote DNSBotnet originally for CCDC, the defense competition. It took me a couple nights. I had the problem in the competition that one of the universities was, they learned that anything with a network socket was bad. And any malware that used a network socket didn't work anymore. So on the red cell, that caused me a minor heartache. So I was like, only leaves the socket open for a couple seconds, sure. And it worked really well. And then we had a client that was like, hey, we'd like you to see what happens. See if you can get out of our network using DNS. I was like, okay, just happen to have this tool. So, and it does one thing, comes over DNS. And then over time it's evolved. I changed the query sizes, I made the query sizes configurable. We had an incident where one of the clients was like, hey, so you were supposed to do DNS tunneling. We're like, yeah, it worked really good. Like, well, we didn't see any. Can you show us what you did? And we showed them, and we were using 16-byte labels, 16-character labels. They're like, well, it's not DNS tunneling, it's 18-character labels. That's DNS tunneling. One could argue that. One could also keep a good client. So just a little configuration option, and hey, we had DNS tunneling there. Also, it's really common, we'll get manager types who are like, hey, I read about this thing, do this thing. Somebody read about DNS over HTTPS, and somebody else read about DNS over, or it's domain fronting, excuse me. So it does that now. Pretty trivial change, actually. It's Go, so it compiles to a single binary. We found that just dropping it on a Windows host, dropping it on a Linux box, works reasonably well. It runs, and it's defangable. It was originally written for C2, so it has C2 built in, but attack defang, and instead of sending shell commands back and forth and shell output, you just give it a number and it'll send you some bytes back. Assuming the demo divinities like me. So we have this, it's a Debian box. Can we read that? Apologize if it's small back there. So we have this. I'm going to run it. I'm just going to beacon to example.com. By the way, this is, there's some networking under the hood so that this is not actually example.com. This is, goes to a box I have. That was it. And it's running. And this should be a Windows box. Here we go. Notice the defang. We'll see that in a second. And both of these will beacon every 30 seconds at most. Longest. There we go. So we see in, hey, a TCP dump. That was awesome. Please? Please? Right, we're not going to see that. And I/O timeouts. All right. Angry demo gods. Cool. So we see me doing more or less the same thing. So we have in the upper left here, it's working on the Windows box. Grabs an ID just from a network card. When I originally ran this, I had no good way to like say, hey, just use this IP address. So it's whatever IP address it can find. Worked really good until I had a whole bunch of Docker hosts with all the same IP address internally. Oops. You can also see sort of the idea. Can you see my cursor? Yeah. So we can see the roughly what the queries look like. Hey, that wasn't the play button. All right, more demo anger, demo divinity anger. Cool. And then there we go. It's running Windows Linux side. And you can see it beacons. bottom left side here, we can see it beacons, and you can see it has these numbers it uses just to avoid caching. Beaconing. Hey, we start the TCP dump. And then, there we go. So we'll interact with implant, the 100 implant, that bar there. Heck, apologies, it'll go away. There we go, we'll interact with it. We'll task it to run a uname. And in a second, you'll see on the right side, the output comes back. It's really long, it's really ugly. Actually gets by a lot of things, so it's a nice takeaway for clients. So we'll task the Windows implant, the FE80 implant, just to give us 1,024 bytes back. Give it a second to pick up the tasking. You can see up here on the upper right, the implant was like, yeah, I ran that. It's good to have logs. It's good to have time-stamped logs. Because invariably, somebody will be like, hey, what did you do and when? You're like, let me tell you. There we go. So there's our kilobyte of tasking coming back. Do that because it's, there's no reason that unencrypted DNS comms couldn't be intercepted. Probably not. There's no reason somebody couldn't change the text record to say, like, blow everything away. All right? Cool. Nope. There we go. Those are backup pictures for even angrier demo gods. So we have some takeaways for both the red side or the blue side doing this instead of hiring the red team. Red teams are expensive and often not pleasant to deal with, so I'd like to encourage blue teams, hey, it's easy. Maybe not this tool necessarily, but some of these, we'll see a few examples of tools that are just quick, easy wins. Anyway, so from the red side, the first thing we learned, especially the first time we were doing this, we're like, okay, how do we get execution on a box that is well defended? And the answer is you put a binary in the box and you run it. So yeah, standalone binaries work pretty well. It was never before seen by a corporate environment when I ran it anyways. By the way, this tool has gotten a little bit of news on the Twitters recently, so if you run it in virus total flags, I apologize. Another thing we learned, make wire comms flexible. Like we had the people we were working with who was like, no, it's 18 bytes, not 16. So a little bit of flexibility is nice. Also a little bit of, hey, yeah, if we just change it up, your sensors don't see it. We had a keybase, it's a keylogger among other things. And we just like put an X in the query. It was HTTP-ish, but yeah, just put an X and like, oh, that was an easy change, didn't catch it. So yeah, make the comms flexible. Because at some point you'll be, the tool will say, okay, that's bad. And then you say, well, wait, what are the other bounds of the tool? Repurposing tools is, when appropriate, is good. Generally, I'm a fan of knowing exactly what your tools are doing, which usually means writing your own. But sometimes, especially if you wrote the tool, you just use it from something else. It's great. Along with getting code execution, having somewhere to host your tools that will get actually onto the target. Unless you're testing like, hey, is anything going to stop something from downloading? Things like OneDrive or Dropbox or EC2, or excuse me, S3, they work pretty good for actually like getting your tools on target without somebody saying, hey, we blocked your binary, sorry. So another thing, have your commands ready, copy paste. Just having a bunch of pastables, and you'll develop these when you're developing and testing the tools. But it saves a lot of typos. It saves a lot of, hey manager, I'm a blue guy, but I have this really cool red thing, and then you typo it, and then the box shuts down, and then you're like, oops, sorry. So yeah, do that in VMs, not when somebody important is watching. And the last thing is to set up your infrastructure ahead of time. Now, we all do that, of course, but set it up like weeks ahead of time. A, to let the domains mature, get categorized, get domain tools to not say they're terrible. But B, because strange things happen. So have them set up a long time before, and then every so often go and check, hey, does this thing work? Hey, does this thing work? And make it look appropriately benign. Now, if we're testing whether defensive tools catch malicious things, you can't make it look like totally benign. It doesn't do anybody any good. You're like, well, yeah, so it looks normal to me, but appropriately benign. If you're not testing domain reputation, have your domains normal-ish. If you're not testing like GeoIP stuff, we had a client that blocked any IP addresses from a large number of countries, of which Togo was one, and I was using some Togo IP addresses. That didn't work too good. Blue had a few more takeaways than those. It was a bit eye-opening when I ran this one. The first thing they learned is, hey, standalone binaries, they work pretty good. You drop a standalone binary to disk, to the desktop, it ran. They got a few more Splunk queries out of that one. So another thing Blue learned was that wire comms are pretty flexible. You don't really have to follow RFCs. DNS, like this one in particular, you don't have to follow like the 150 RFCs. And yeah, we changed it up just a little bit, and they're like, oh, DNS can do that. Okay, let's adjust, and they got a lot of value out of that. They learned that even if your malware isn't super cool, elite, run by the KGB, it can actually still work enough. Everybody wants to find an APT. Everybody wants to say, oh yeah, we caught APT1 or choose your group. Doesn't necessarily mean that the malware isn't going to work, isn't going to cost you money in the end. It's what people are generally defending against. Blue also learned that DNS is kind of hard to see. Kind of alluded to some round robining we found, and they caught most of it. We had a client where NX domains came back as, they were using, I forget their upstream DNS, but they're like, hey, here's a parking page instead of your NX domain. Looked kind of normal, kind of gave us credibility, worked pretty good, sort of. But yeah, DNS, and then we had another client who was like, here's our solution for DNS. We'll encrypt all the DNS. I assume it was DNS over HTTPS or DNS over TLS. We'll encrypt all the DNS. And then they're like, hey, we're not seeing your emulations. What's up with that? So maybe that wasn't helpful. And it was a good lesson, good takeaway for them. And the last thing for this tool is domain blacklists are not always effective. And domain whitelists are not always effective. So when you whitelist things that are like good category, good category, good category, and I'm like, hey, look at my medical article on nose hair. It's awesome. And I cited Wikipedia. Then, hey, it works pretty good. And blacklists, hey, these are the bad domains. And we generally try not to register domains on site. But every so often it's like, okay, we're out of the good ones. You need to do more than we expected. That worked. All right, the next, pardon me for a second. Next emulation is PSBeacon. This is on GitHub. By the way, DNSBotnet, the link right there. PSBeacon, here we go. It's a GitHub gist, so apologies for the short, really long link. We had a client who was like, hey, yeah, so you do all this HTTP stuff. We read about things that's just like query, answer. Linux lady came up in some conversations and like, hey, how's that look on the wire? So I wrote, and it was Windows endpoints that we were using at that point. So I wrote a little PowerShell script that was more or less the same thing as the little bash what would be a one-liner up there. Notice critically, the important kicker part is not in play. And that goes back to the make things reasonably realistic. Yeah, I mean, it's going to pipe to standard out, but could write to binsh, could write to a shell. And there's a 60-second beacon, excuse me. It's pretty much exactly what Linux Lady did, except on a Windows endpoint and not in cron. So it was cheap to write, definitely hit that wicket. It was like minutes to write. And over time, it's evolved. Features we've added jitter in there. So some things will say, hey, we've just noticed every minute something is happening that's bad. So if it's between like 1 and 3 minutes, might be good, might be bad. It's good to test the limits of your tools. And then the user agent is settable. You can configure it to be whatever you'd like. One point we were running this and they're like, hey, that tool was cool, but nobody uses PowerShell's IEX, or IWR, excuse me, in our environment. So that really wasn't what they were trying to catch. So yeah, but generally it works pretty good. A couple little snippets of code. So this is the config, the things you can set, A, but B, defaults. And the defaults are very important when you hand something to somebody and say, hey, please run this. And that somebody's like, what's a command line? And you're like, please double click this. Having the settable defaults is really quite helpful. Also, if you're using link, by the way, little takeaway, link likes smileys, and PowerShell does not like smileys typed in. Link likes turning things into smileys specifically. This is the core of the code. It's actually a really simple tool that we use very frequently. And defenders actually get a lot out of it. A lot of like, oh, wow, that worked. Okay, retool, or change the procedures, or what have you. And the core really is just somewhere in here. System.net.webclient that download string, pass a URL in, pipe it to out null, and then, yeah, but you're not actually running anything. We're like, well, okay, we didn't want to, but if you really need to, you can change a few bytes right there. Demo gods. Hey, there's an iTerm update, by the way, in case anybody was curious. Please. Ken? So we're asking me, hey, is that mic going to work? And I was like, yeah, no problem. Thank you, sir. So here's what it looks like on the wire, also command line parameters. And it looks exactly like you could expect from curl in a loop, or system.net.webclient in a loop. Somewhere between 3/4 of a second and a second and a quarter, it makes a request, and that's pretty much it. Again, I'm not, and please don't go abuse example.com. You can, but it's not polite. And that's that tool. And we get a lot of mileage out of something that simple. So red takeaways, things we've learned. And by red, I mean blue guys acting red, or the red guys doing this. Tools evolve over time. When we started this, it was that big. Now it's 80-odd characters or 80-odd lines or so. And we've just had different needs over time, like I was talking to the user agent. Next thing we've learned running this is to let built-in systems be built-in systems and do what built-in systems do. Our original incarnation of this was written in Go. Go can handle Windows proxies and read WPAT and all that fun stuff. Or you can write a line of PowerShell and it works just as well. So, and we've had the same issue with DNS. Like, okay, we need to shoot this at the right DNS server, or just let Windows do the DNS. excuse me, talked about the configuration from inside the script. This is not to say like, go to line this and change this. This is not to say like, okay, here is sed will change it, or here's a vim find and replace. You know, just something at the top, constants or what have you is nice, plus configure or command line arguments. This was an interesting, oh dear. Well then, this was an interesting little takeaway. IEX IWR actually works pretty good. So again, we're like, okay, how do we run this? They're like, oh, our execution policy is to prevent that, and the profiles won't let you do anything. And we're like, okay, we'll just pull it down and see if it works. So it actually worked pretty good. And it was a nice little finding for them too. Also while writing this, certain managers who may or may not be in the room like to ask for features. And certain managers usually know what they're talking about.
Tell the story.
Because I don't want to be fired. Anyway, so he's like, hey, Stuart, you got to make a settable user agent. That's what's going to get us caught. I'm like, you know, I'm doing other things. Hey, you got to make a settable. Yeah, so sometimes feature creep is a good thing.
It happens.
It happened. But generally say no, and that's less to maintain and less that can go wrong for sure. Last little red takeaway is there's this blurry line between what is a shell script and what is a shell command. The difference between a script and a program, that's pretty obvious. Compile it, it's a program. But the difference between a shell script and a command, if we go back here, is that a script or is that just a command on 4 lines? And you know, we've had people who are like, hey, you can do things, but just don't run any scripts. Scripts are something we don't want. So staying within the spirit of what was asked is, you know, you got to make sure that you're not going to anger people. So Poor Blue, with such a simple tool, they're like, oh, it's a simple tool, no problem. So our Blue guys have come up with various sim queries to find PowerShell run from the desktop and for the download execute thing. They're like, yeah, sure, we'll look for that now. It's kind of funny when you're like, you show somebody something and they're like, give me a second. And then 10 minutes later, they come back and say, hey, I ran this query. Was that you a month ago? And you're like, no, looks like me, but that wasn't me. I don't know what happened with that one. They wouldn't tell me. So Blue also learned that PowerShell profiles and execution policy and whatnot, they work in some cases. If you have PowerShell 2 for backwards compatibility and you turn them off, they don't work very well. At Blue, in this case, you put code on a safe site, and pretty much anything hosting text where you can put up text that is trusted by the environment, it'll come right back down. So it was a Blue team that had a bit of a mental adjustment about what is safe and what we should allow, and also that HTTPS works pretty good. Logging needs to be used and inspected, and if you don't, you end up looking like that, I think. But you know, they're like, hey, we got all this PowerShell logging, you can't get anything running, and then they're like, we don't look at the PowerShell logging, so please pretend we did. We've had teams find their beaconing detection intervals, like, hey, yeah, everything, you know, we don't even bother if things beacon at minute intervals because the Maryland MVA does that. We've had teams like, well, I mean, an hour every day, it's not going to really cut. So it's especially this tool is nice to find exactly where those bounds lie. The last thing we found, it was a blue and a red thing, was that PowerShell and Explorer can use different proxies. So we were having a devil of a time pulling our code down, just typing it into Explorer. It's what the client gave us. And we're like, hey, what if I try this IEX IWR thing? Surely it's blocked. Whoops. All right, so I lied. There's actually 3 emulations. Apologies. One time we were having a pretty rough time at a client, and they're like, hey, get some DGA on the wire. Find something. And I was like, okay, and I did this. And this is the first one we'll see that it's just, a really simple 30-second, tested appropriately off their network, but it was pretty fast. It worked. And then of course they came back and like, yeah, but that's not actually malicious. And I said, well, okay, imagine those random bits. And by the way, the bash random variable will give you like 15-ish bits of random-ish number in decimal. And they're like, yeah, it's not random. I'm like, well, replace dig with curl, replace random with the MD5 hash of the day, and pipe it to SH. So, and then you know what days you're going to be running it, and you can hash it. Maybe throw an hour in there if you want more domains than anybody cares to block. It was a nice little learning thing. I'd like to leave you with some easy wins, some little things that you can run. Red, blue, management, IT, whoever can run just to test things. So port scanning. Netcat has a built-in port scanner. Turns out ish. I mean, it doesn't do anything fancy, but it just makes it Cincinnati, FNAC sort of deal. Also, teeing it to portscan.out or whatever log file is great. It's really good to have a especially time-stamped copy of what you've done. Lateral movement's been getting a lot of news lately because generally it's hard to see inside a network. It's not as well instrumented. SSH has that built in. I was working with a team that were dead terrified of the wiper. That was their shtick. We were going to defend against a wiper. Sony had happened not that long before. we have to plan for the wiper. What's a wiper? What's a wiper? Brute forcing creds, test if lockouts happen on your website, test if something's going to alert and say, hey, this dude's logging in about 100 times. Test if the fax machine you just bought will let you in. User share dict words is on at least Macs and BSD boxes, and I think most Linux distros. Last set of easy wins, exfil. This is not an original concept. A friend of mine was like, hey, yeah, you wouldn't believe what security asked me today. And he's like, so we just had this box that had flat, high network usage. And I was like, that's weird. He's like, yeah, somebody was SCPing off their code base for days. It was more or less that. Domain fronting also has been getting a lot of news lately. Domain fronting is actually pretty easy to test. It's that. You have to find a benign domain and a bad domain that are frontable. Please roll your own. Don't use anything you're not allowed to. DNS tunneling, same thing, has been getting some news lately. That will test what happens if you have a bunch of queries to a parent domain with different subdomains. DNS over HTTPS, especially in the last like 4 days, I've been noticing a lot on Twitter especially. Google's kind enough to provide us something. Replace name with something that is not going to get anybody, I mean, don't use something actually malicious. Don't be like, threat intel, unless it's what you're testing. Unless you're testing if your threat intel stuff works. And then for the managers who like buzzwords, DNS over domain fronted HTTPS works pretty good too.
Thanks, Stu. All right, so I hope you guys got some entertainment out of that. Imagine working with him. All right.
Imagine working with them.
He likes cats, as you can see. So some of the key takeaways from what we discussed today: defenses are complex. Threat emulation, allows defenders to kind of test this. Red teams, I recommend you kind of add this to your arsenal, but blue teams, everything we did there is very easy to emulate. A lot of the tools that Stu discussed earlier are being released. Planning, I don't know how many proxies we've run into, how many firewalls we run into, signature, things that the client doesn't know this in their environment to cause us issues when we arrive. And that's with really good rehearsals prior to our engagements. And as you saw, some of these emulations, they're just PowerShell one-liners. Many folks in the room could spin these up in seconds, and they have just great value without having to go out and buy a third-party tool or fancy license to do these things. I would say don't invest in those things until you have proven that these things get caught. And then simple tools, some of these are a couple megabyte binaries. That's just because Go is really fat when you compile it, and the rest is again the one-liners. And then always a challenge the assumptions, because a tool says it does something doesn't necessarily mean that. And also sometimes the only adversaries that some of these clients are seeing are red teams that are sharing techniques. So they may be getting really good at defending against the different red teams they're partnered with, but are they ready for that APT that's going to come in? So iterating through these minuscule threat emulation scenarios is be pretty beneficial. So where do you go for more information? Stu kind of talked about he loves Tor. He loves Tor also. He loves Go language for developing some of our emulations. He's released DNSBotnet publicly, and PSBeacon, we threw a gist out there for it, and then some of our easy wins that you saw on the last two slides he briefed. So you can go and pull all those down. Apologies. All right. Awesome. So we used to work for Air Force General, and we were told we had 50 minutes, so we're sticking to that. Any questions? Any Air Force in the room? Time hacks, things like that? No? Time on target? No? All right. So there's how you get in touch with us. If there's any questions, we have a few minutes. Also, we can talk outside. I started that late. Thank you.